actually covers.
Welcome everybody to today's heat pump webinar. Today we are talking about heat pumps and retrofitting existing homes that have ducted systems. Dave's going to give you lots of information about that and just heat pumps in general. I hope that you'll all find it very valuable. Let's go to the next slide, Cody. Just a reminder of some housekeeping items. We will be recording today's webinar, so we'll send a follow-up email out with the recording as well as all of these slides. If you have any questions, please put them in the Q&A box, and we'll make sure that Dave gets those questions during the webinar or at the end of the webinar, and we'll get those all answered for you guys. This is a list of all of our heat pump webinars we have happening this spring, summer season. This one, like I said, is for ducted systems. The next two on July 26th and August 16th are for new construction, for new homes. So we're really going to focus July 26th on new single family homes, and it's going to be geared really more towards those homeowners. And then August 16th, we're going to talk more about new homes, condos, and townhomes, more directed towards builders, architects, and developers. All of those webinars start at 5, and you can sign up in that website or with the QR code. Next slide. These are our heat pump webinar sponsors, so thank you to all of our sponsors that helped today make these webinars possible. We have some nonprofits from the Higher Mountain region that offer rebates, as well as Holy Cross Energy Co-op electricity provider, which offers rebates, the Beneficial Electrification League of Colorado, which shares information about heat pumps and rebates across the state, and then Energy Smart Colorado, which is really the program that our rebates facilitate offering rebates for those improvements in homes. Next slide. LoveElectric.org is a website brought to you by the Beneficial Electrification League of Colorado, and it has all kinds of resources for you. So I encourage you to go there. You can find information about rebates across the state, as well as contractors across the state that can help you make upgrades, and then technical information and information about what that technology is that you might need in order to make your home all electric. Next slide. Holy Cross Energy, as I mentioned, is a local co-op up here in the high country that offers rebates. The residential rebate for a heat pump is $5,000. If it is new construction, they do have even more money available. But basically, if you're getting a heat pump, they'll rebate 25% of the project cost. Most likely, you're going to get pretty close to that $5,000, if not all of it. And at the bottom of this page are the requirements for that heat pump rebate. Most of the nonprofits in our Higher Mountain region area have those same qualifications on their rebate list, but definitely check out each entity when you're looking for rebates. Next slide. Energy Smart Colorado, as I mentioned, is the program that all of these nonprofits you see listed here offer in the high country, in their local areas, and those programs offer home energy assessments and rebates for improvements in homes and buildings. If you're in any of those areas, these are the nonprofits you would contact for this information. Next page. And then rebates. So these are four sponsors, the four nonprofit sponsors of today's webinar. High Country Conservation over in Summit County. If you're up to 160% area median income, you could get $4,000 in a rebate for a heat pump. And Walking Mountains Science Center in the greater Eagle County area, we have up to $5,000 available if you're up to 150% AMI. If you are above 150% AMI, we have $3,000 available. Core over in the Roaring Fork Valley, they have $7,500 available to Holy Cross Energy households, and then $12,500 available for Aspen Electric households. And then Clear at Garfield Clean Energy, they have $4,000 available through their Re-Energize program with up to 150% AMI. And then if you're in Glenwood Springs Electric area, there's up to $3,000 available. So reach out to those local nonprofits you see on the screen for the rebates and get more details. And not to forget, there are also tax credits out there, both federal income tax credits and Colorado income tax credits. So the big difference here to point out is that Colorado income tax credit is for new and existing homes. So if you're doing new construction or if you have an existing home, you should look into those Colorado income tax credits. The federal income tax credits are really specific to existing homes. Next slide. And Dave, I want to introduce our instructor today. He is David P. Troy with over 15 years experience in a range of renewables, energy, sustainability, and business roles. He was the founder and president of Blue Valley Energy, a successful ground source heat pump engineering, design, and installation company in Boulder, with over 200 installations throughout Colorado. During the early 2000s, he led technical sales of solar and energy power systems for residential and small commercial businesses. And most recently, he was the sustainability manager for Golden Aluminum, one of the largest single-site industrial power users in Colorado. He was responsible for leading adoption and implementation of a facility-wide energy monitoring system there and upgrades to reduce energy consumption on large-scale industrial production processes. And then in 2017, he launched NTS Energy, which is how we know Dave. It's a consulting company focused on providing advanced HVAC and solar solutions to homeowners and small commercial industrial companies, and promoting the transition to a new energy economy in Colorado. Dave holds an MS in geophysics and a BS in zoology. And Dave, I am going to pass it over to you and let you share your slides and take it away.
All right. Thanks, Nikki, and welcome, everyone. Let me take a second here to get this sharing right.
And while Dave's doing that, just a reminder to put any questions you have in the Q&A box.
Almost there. Okay. Does everybody see that? Okay, welcome again, everybody. Just so you know, I have somewhere around 30 slides, and it usually takes about 30 to 35 minutes to go through it. And some of them I'll go through fast, but everyone's going to get the deck, so you'll get all the details. We'll skip the next couple slides. I looked at a lot of names on the call. I think we're not going to spend a lot of time on how it works. We'll talk a little bit about how heat pumps got to where we are now. Today's is a very focused talk on ducted houses. We will have a side advertisement for mini splits, a couple slides. And then we're going to talk a lot about how, and this is really geared toward the homeowners, this talk, and there's how do you know that how do you know what you're going to get, whether you get a good system. And Nikki's already been through the incentives. So a heat pump, just for those of you don't know, there's videos out there explaining how they work, etc. But basically, it's a reversible air conditioner. And the way to think about it is how does it work when it's really cold? It moves heat, not temperature. So even if it's really cold out, there's a lot of heat in the air. You have an outdoor unit that looks like a standard air conditioner or a little bit different design. Inside of this, you have refrigerant, which is kind of a magical chemical that basically loves to absorb heat. So what happens, I'll just go through it in about 10 seconds here. Air blows by here, the refrigerant pulls in heat from the air, it goes into a gas. We do need to add energy. We need to get this up to about 110 degrees. So that's the compressor, compresses it in here, goes in your house, goes into a unit that's going to be, or is it a coil on top or inside? And you're going to blow air by it, and it's going to give off its heat. Or in a mini split, it's going to go into here, give off its heat, and then it's going to expand back and liquid, get cold, and go again. And in the summer air conditioner, this thing just reverses. Inside these units, the only differences are controls and a reversing. So the reason we can have these talks and the reason that heat pumps are now becoming a big deal. In fact, I just read something the other day. I think last year, heat pumps actually passed furnaces in terms of numbers sold. So that's how fast adoption is happening. So what happened? Well, let's talk about cold climate heat pumps. So back, heat pumps have been around a long time. They were in the South. They would cool in the winter, cool in the summer, and heat when it was mild. But then around the early part of the century, I'm calling it kind of the birth of cold climate heat pumps. I probably should say in North America. they were around in Europe and Japan a little bit earlier. But in the early part, was a lot of efforts on defrosting. Why can't we use heat pump when it's really cold? We should be able to do it. So a lot of research, a lot of trials. And then the last 10 years have been being installed. New England, Midwest, Canada, lots in Colorado. So these are systems that are designed to work well when it's really cold. And for engineer folks, the nice thing about heat pumps is there's lots of fun stuff to work on. Every component, the compressor, which is what uses the energy. There's lots of design, lots of intricacies in the compressors, making them better. How do we defrost them? Even the alloys, how energy goes back and forth, etc. The fan blade design, and a lot of big thing is computers and modulation. So it used to be heat pump on, heat pump off. Now with these new compressors, the heat pump can vary as much as you need it for the heat. Not only the outdoor unit, but the indoor unit, they're matched. So all these things have been resulted in some great advantages, huge things. And the first thing is the ability, the capacity to heat your homes when it's cold. We have an outdoor temperature on the bottom, 0 to 60 degrees. And on the left side is how much heat or heating capacity you need to heat the house. And the green line is just sort of a typical house. And obviously it needs more heat as it gets colder. Well, this light blue line is a long time ago. This was the heat pumps for the South. So it'd get near freezing. They wouldn't really be able to, they'd be below the line of heating capacity. People didn't care. They didn't really need them for that. Well, over this evolution to cold climates, the orange line is what, cold climates, the advanced cold climate heat pumps can do. And notice they can hold capacity, whatever they can do at about 45, 50, way down to 10, close to 0. Then some of them will either hold it below 0, tail off. Now there is obviously this little wedge up here and in here, and we'll talk about that. The heat pumps are paired with sort of a secondary supplemental source. But notice this is the evolution of all this capacity. Now I've added a red line in here, kind of an intermediate one. That's not as well defined in the industry, and it does cause homeowners some misunderstanding. These are high efficiency heat pumps, and they can work in cold climates. They're not quite as good as cold climate heat pumps, but notice typically they'll be able to heat homes somewhere down in between the 15, 25 degree range. And then these are possibilities to pair with furnaces and dual fuel systems. So we'll talk about that option also. The second thing, another big thing, was not only capacity, another was efficiency. And HSPF, heating season performance factor, is another way to measure. It's a way to measure efficiency. The higher the number, the better. 12 is twice as good as 6. And I'll mention it now. They just came out with a new standard called HSPF 2. And so most equipment you'll see measure will still have HSPF, but 2. I'll mention that a little bit later. But anyway, the principle is the same. The HSPF, the higher it is, it's better. This is 2012 over 2020. Now it's 23. Notice that basically it's gone up and the efficiency is improved by anywhere typically 20 to 30%. So this is sort of the range where many heat pumps are available. This is kind of the highest end. So that's another big deal. And that reflects directly in lower operating costs. So we've got efficiency improvements. We've got the ability to heat higher capacities below 30 degrees. We've got the ability to heat below 0. And we've got the ability to defrost when the system's ice up. So altogether, now we've got great product. Today, we're focusing on ones. You have a house, you've got some ducting in the house, you've got a furnace. What can we do with heat pumps? And so we'll talk about a couple scenarios. This is a heat pump. The outdoor unit is, like I said, air conditioner. This is all electric, no no furnace situation. Indoors, you'll have an air handler, which is about the size and shape of a furnace with electrical inside as kind of the secondary source, electrical strip. The other option is called a dual fuel. You have a heat pump, you have the furnace in here still, coil on top. Basically, think of using the furnace most of the time as the blower system to heat the house with the heat pump, and the furnace is the secondary. So we'll talk about both these strategies. So now a little aside for some of the other webinars, but also since everybody's here, and I know someone mentioned in the chat already about mini split. There's mini split ductless systems. I think some of you know about it. And the reason I'm mentioning in today's talk is some of you might not have situations where you want to do a full replacement. So I'm just going to introduce them in 2 slides. There's an outdoor unit, and instead of going to ducts, you have refrigerant lines, which are on the order of a couple inches deep. Think of they're about the size of maybe a 3-inch diameter little circle. And so these can run in existing houses. You can figure out ways to move them, and you can have these wall units or other kind of units in rooms or certain areas of your house. So they're kind of independent systems, and they're very easy to retrofit. Well, you might want to do some certain things rather than replace everything. You might want to just have a second floor. You want to cool, or you want to, if you have electric baseboard or boiler heats, you can do this. Like I said, this is a whole separate talk. And if you want, you can request from Nikki and Walking Mountains, the video or the slides. But there's a few nice applications for this. So that's kind of the sort of the side teaser on the mini split world. So the heat pumps, well, there's real, this is a better product than existing stuff that was in 10 years ago. The way of putting in AC and furnace is becoming just basically obsolete. They use less energy. They use about 1/3 the energy averaged over a year. That's the measurement, for those of you who aren't familiar. It's called COP, coefficient of performance. What that means is I put 1 unit of energy into a system, and how many units do I get out? A COP of 0.95 as a furnace. A furnace is 95% efficient. So think of, I put 1 unit of gas equivalent energy into that, and I get 95% out. A heat pump says I put 1 unit of electrical energy, and I can move 3 units, average over a year, into the house, 3 units of heat energy. It does, cooling also. You can think of it, it's nice that it eliminates, everyone's thinking globally now, which is great, but think in terms of neighborhood, in terms of our house. It's eliminating emissions around your neighborhood. It's going to have a big impact on your heating bills versus propane or electric. It can help if you have against natural gas spikes, if you do a combination, and it helps with GHGs over time, and especially as the grid becomes more green, renewable energy, it's going to help even. So let's look at just a couple scenarios here. What are the financials? What am I really looking at? This is kind of a typical couple 1,000 square foot house. I just done a model of 4-ton, and it says, all right, I'm sitting here with a propane furnace, and it's costing me, well, let's say it's costing you $4,000 a year to run. If I had an AC on, it would still cost that much for heating. We're looking at the heating right now. So I can say, well, I can put a heat pump with an air handler or a heat pump with propane, furnace combo. Furnace just used a little bit as backup. I'm going to save a lot of money right here. And so here is the cost now. And this is, I think, what's really exciting about it. So furnace, everybody I think knows right now, putting in systems is becoming quite expensive. And the idea is these prices aren't perfect, but we're trying to get them in the ballpark. So let's just say 12,000 to put a furnace in. It might be 10 to 12. Furnace with an AC, the AC is going to add on another $10,000. Wow, let's look at what I can do with the heat pump and the air handler. 24,000 I've got all these nice rebates, Walking Mountains, Holy Cross, depending on your, consider this the utility. This is pretty typical of utilities, other rebates. I've got the state tax credit, federal tax credit. Wow, 13,000. It's almost on the order of furnace. Basically, I'm getting my heat pump part pretty much covered. And then the same if I just go with a heat pump and I add a furnace together, the dual fuel, all new, very similar. Now, here's another thing a few of you might be thinking about, and we'll talk about this a little bit later on, a few slides. Well, what if my furnace, I just bought a new furnace 5 years ago. Well, I just had this for a client not too long ago, in the past month. So they added a heat pump to their furnace. In this case, you still save a lot on your propane, maybe a little bit less because sizing, but we don't need to get into details. And look at what I can get that for under $10,000, and I'm saving a lot. So in a couple of years against propane, I'm basically I'm going to get my money back and save more. So natural gas, and I'm going to say, you know, you can really get in the weeds in here. Some people could say, no, you save a lot of natural gas. I'm going to say it's on about on par, because it really depends on gas. If gas is 80 cents a therm, $1, $1.20 a therm, if electric's 11 cents. But basically, if you start running enough of these with the way things have been over the last couple of years, the heat pumps might save some, or it might be a little bit less. So, but anyway, on par. And this is what this is, annual heating costs on a model. And so, you know, plus or minus a little bit. But realize, though, in the end, you're reducing your natural gas use by quite a bit, depending what you want to do. If you're all electric, 100%. If you're in one of these dual fuel modes, anywhere from 80, typically 80 to 90%. And I have more exact numbers in one of the subsequent slides. Wow, so what about the cost situation? Again, it's pretty much on par. Like here, oh wow, you know, my heat pumps with all the rebates are about like the furnace. Man, if I wanted to add AC or just do AC, my heat pumps win. I can add a heat pump with existing furnace. Okay, I might not save a lot on my annual energy costs, but I'm going to get cooling, and I know I'm going to reduce pollution. I'm going to get all the sort of green benefits that I desire. So right now, you know, this is really just a fantastic technology. But let's make sure we want to get a good system. And the point of the next back half of this talk is, how do you know? I mean, we're not expecting you to be contractors and be able to put heat pumps in, but the idea is, what's the right questions to ask? What's the knowledge? How can I think about this? So avoidable errors, because there's still stories that come around. They're becoming less, but they're still out there. Hey, I'm not saving as much on my bill. Why is it defrosting a lot? We're going to talk about how to size and options. We'll talk about equipment specs a little bit. How do you make sure that you're getting a good install? How do you figure out, you know, how do you work with contractors, and not just select, but really work with them as a partner? And what about product quality? So here's what's happened as heat pumps got installed in Colorado in sort of colder climates. So people are like, wow, it's not really working right. Well, it might not be a very high efficiency. Might not have been a good heat pump. Might not have had capacity. People might be saying, well, no, I expected it to heat down to 15 degrees and it's really not doing it. Well, maybe the system was undersized. And I've seen cases where the system actually was sized right, but it was just set up. Actually, this has happened several times where the heat pump, it was set up in the controls. Oh, the heat pump only heats down to 30 and then it goes to the furnace, but actually the heat pump could have been set to heat down to 20 or 15. And sometimes, you know, a poorly installed system, if you don't make sure the ducts are right for the system, if the line sets aren't done well, if it's not elevated right outside. So these kind of things, and they're rather easy to avoid. And that's kind of what we'll talk about, you know. And I'd say there's a rapid acceleration in the number of contractors that are comfortable doing this and realizing some of the nuances of heat pumps versus say just AC. So let's talk about strategies and the reality of how these things work given the climate and temperature. So this left side here, this is the monthly temperature range in Eagle, Colorado. And in the next couple slides, we'll talk about how the heat pump sizes happen and what you'd be. But typically in a dual fuel, you'll have a heat pump that the heat pump will do almost all the heating from say 9-10 months of the year, from mid-February through November. And then in the last couple months, the furnace would do the majority of the heat. So, so that's, and one thing to remember is with this COP, it's an average. Quite honestly, in the months of September, October, man, the COP of heat pumps are 4 and 5. So you're really getting an amazing amount of heat for low energies. Then it decreases over. Now with a heat pump, if you want to go all electric with a ducted system, you'll have some electric strip in there, which will help it when it's really cold out. And actually, in certain cases, it will be the bulk of it. So you want to minimize that. But so you upsize the heat pump, and it's going to do 10, 11 months of the year. It's just during the really coldest times where you're going to be much more dependent on the electric strip heat. Now, how does that translate into the actual amount of heating? So this is a different way to look at it on the right. And this is outdoor temperature -20 to 65. And this is the percent of annual heating. And so it's a little surprising because you think, wow, when it's really cold, that's when I use most of my heat. And that's just not true because the number of hours. So if you look at this diagram at 15 degrees and above, over 80, basically about 82% or so, less is energy is when we're heating here, and it's less than 20% when it's cold. Now, when we look at them, next few slides we'll explain a little more. So if I got a heat pump that is sized up in my existing home that flips over at about 15 degrees, my heat pump's going to do, wow, 82%. And then my furnace is going to do less than 20%. So it looks a little weird. I mean, it's just in these couple months here is this wedge. Now with the electric strip, I want my heat pump to do more because this is not very energy efficient and expensive. So really what happens is the heat pump will do, and it depends how you can get it sized, but we're going to try to get it a little bigger. And then the electric strip will take a lot of this when it's super cold. And in here, there'll be sort of this combo where the controls will say, heat pump, electric strip, back and forth. So that gives you an idea of end of season, how these systems work. Probably everyone here on the call, but maybe some of you aren't familiar with terminology. BTU per hour is how much heating my home needs. And it ranges 24 to 100,000. It might be more, but this is like be a small condo. This would be, typical homes might be in here. And furnace sizing, when people talk about furnaces, they're always 48,000, 60, 80,000 BTU. Heat pumps, contractors will talk in terms of tons. 12,000 BTU hours a ton. AC is also in tons. Just cooling tons, same difference, same thing, 12,000 BTUs required for heating or cool. And so typically, heat pumps are going to be 2 tons to 4. There's a few in the cold climate world that are 5, but that's limited model availability. So really, this is kind of the range. And if you look at model numbers on heat pumps or air conditioners, these are the model numbers, 024, 030, and it's kind of funny, talk about tons this way, but model numbers refer to that. Just to give you an idea, when you're talking to your contractor, What does it mean when he says tons? So we have an existing home, and the strategy is different than if you were building a new home. If you're building a new home, first thing you do, oh, what's my load model? How much heat does my house need from the ground up? Design my system. Well, you've already got a system, and you got some stuff in your house. So the first question is, how much electrical panel do I have? What size electrical panel will support the system? And if you need, it's like, wow, if you need to do an upgrade, that's going to cost a few thousand. You're going to, there's some local rebates for panels. But one thing you think about as your contractor helps you look at your panel, we'll talk about this in the next slide. What's my future plans with electrification? The other one is, what's the maximum size heat pump my existing duct system can support? So because heat pumps use lower air temperatures, they tend to need a little more bigger duct system than furnaces. And so the duct system that you have in there is only going to support a certain size heat pump for the heat pump to work well. And one of the things we'll talk about is, hey, Mr. Contractor, can I do a few things to my duct system to make it a little bit better? Maybe I can put in a little better bigger heat pump. One thing, don't get confused. There's not infinite possibilities here. Right? You're not going to come in and you're going to, even if you had 10 contractors, they're not going to come in and give you 10 different sizes. I mean, typically it comes down to, oh, is my house a 2 ton or 2.5 ton or 3 or 3.5 ton, 2 or 3 tons? So it's important to get it right, but it's not the end of the world. I mean, it's not going to be that complicated. And in the end, if it's a little question mark, you tend to move up in size. So the electrical supply, we're not going to go into details. You can read the slide, but it gives you guidance, size of heat pump, and breaker size. I really forgot to take out just these 6 and 7 tons. I don't that, you know, for residential, that side. Now, if just as guidance, if you have a 100 amp service panel, it might limit you to like a 2 to 2.5 ton heat pump. If you have 150 amp, probably get more, and 200 amp, you should be able to get pretty much whatever size. So just, it's kind of gets it into your head. Hey, if I'm 100 amp, I might be constrained a bit more than 150, et cetera. But your contractor / electrician will be able to really clarify it for you. That's number one. Number two is, I've got a bunch of ducts in my house, and the ducts can be accessible in the basement, or they can be totally drywalled in. So the contractor's going to know, and he can measure and figure it out. There's ways to do all that. Well, how do you know? Like, what's some guide? So if you have an existing AC unit, which I know in the high country, maybe not a lot, but Front Range Western Soap, you know that the duct system basically can handle a heat pump of the same size. And so that's a pretty reasonable rule. And so you can say, all right, what size is my air conditioner? And the contractor say, hey, air conditioner is 3 ton. You know, that's a pretty good size. In the high country, because, and this is, I'm going on a tiny bit of a limb here, but the cooling needs in the high country are lower. So typically the air conditioning sizing a bit lower. So I'd say just a ballpark, in the ballpark, that, you know, if you have an AC unit up there, you probably can get away with a heat pump that's maybe a ton larger. But this is just guidance. So when your contractor starts talking about this, you can understand it. What if you don't have an AC unit? Well, now I'm going on a bigger limb, but okay, what might my heat pump say? I mean, you can say, I'll look at the furnace and take about half the capacity. So if it's an 80,000 BTU furnace, 40,000 BTU heat pump, if you remember the numbers, that's a little over a 3 ton. This is just really rough guidance, but that's something to think about. And so in the end, if you look at a lot of the houses that been built for furnace systems and stuff, and you say, well, without really doing much to the ducts, how big a heat pump can I typically? Typically, you can put in heat pumps that are going to be able to heat your house down to minimum outdoor temperature somewhere in the range of 15 to 25 outdoor temperature, somewhere in there. So the contractor and you look at electric, you look at your ducts, and he says 3 ton. We probably can do a 3 ton. Say, well, okay, how much is that going to do for me? What will that do? So back to this little diagram, and it has outdoor temperature 0 to 60 and up here. And so this turns out to be your load, and ignore these little bubbles here. Basically 3 ton, he's going to have a line. He's going to say, this heat pump I have has a capacity and it can cross at 25 degrees. So the heat pump that I think we should do can do 25 degrees. Or I might say, the heat pump I can put in can go down to 15 degrees. And then whatever the secondary heat is, that'll have to do a lot of it. So what does that mean? Well, if he says to you 25 degrees, the heat pump's going to be able to do about 63% of the annual heating. The backup source is going to have to do around 37%. But the heat pump's going to run most of the time, and the secondary source is going to run less because it's colder, so it gets a higher percent. If I can get down to 15 degrees, 82 and 18. So as you get, as your cutoff or your changeover gets lower, it helps. More heat pump. Now, the one thing you can talk about is, can we do a few small duct changes? And I talked about, it's in the writing in the previous slide. Can we add a couple little supplies? Can we do returns? Can we improve the ducts a little bit? Not a lot of cost. Is it possible? Is it accessible? And if I get another half ton size, I gain 10 degrees typically. So, so that's what, you think about, can we do a little bit better? But honestly, and a lot of times the duct tape system might be 20%. Now, one thing I had to mention, these numbers, if you're going with the dual fuel, is fine. But if you have an all electric, and it's in the slide below, you want to have a heat pump size that it can do down to 10 or 5 degrees, because you do not want to be doing these amounts of energy use with electric strip. You want that to be minimized. Way too much text. I gotta make this slide better, but here's the thing. What do you do with a furnace? Should we throw out the furnaces all the time? And, we don't want to fill landfill with good equipment. So there's somewhat of a judgment call. I used to go 15 years, 17 years, 15 years, 17. Now I'm hedging. All right. If it's so if you read in all the literature, people say the furnaces will last an average 20 years. I mean, if you try to find where all these statistics come from, you can't ever find. But 20 to 30 years, furnace is going to be around. So 15, 17 years or younger, and it has an ECM fan motor. This is really important. This is an energy efficient fan. If it doesn't have this fan motor, it's going to use up way too much energy running the fan. My recommendation is you keep your furnace. Now, you want to purchase the number one, you don't have to, but it really makes it's a little bit better. Purchase a heat pump from the same manufacturer if possible. I'm not going to read the fine print, but it basically are the manufacturer around it. And then 2 levels of heat pumps with your contractor, because the contractors are going to say, your furnace technology is this level. Here's the heat pump that I think matches that. But it's almost, the analogy I'll give is if you had an old computer and you wanted to keep it running for a while, and you wanted to put in the right memory chips, the person would say, okay, these are the generation of memory chips that will work well with this. I can put these super fast memory chips, but it might be a little tricky. Anyway, talk to the contractor. Hey, what's the best one? But I really like cold climate heat pumps. All these rebates, they're more efficient. Give me an option for that. Tell me how that'll work. And they should work. It just means the technology is a little bit different, and the contractor might have to tweak the settings a little. Every utility has massive rebates for the cold climate, and a lot of them have it for These I call them energy efficient ones. Holy Cross just has for the cold climates. If it's an older furnace, throw it away, get a dual fuel, get a match system, and talk about different options. If you want to go all electric and it's an older system, obviously throw it away, and we'll talk about some of the things in the next slide. If it's a really young furnace and you want to go all electric, you can do it. I guess you really need to think hard about how much you're gaining by doing that from an environmental point of view. So all electric. The heat pump needs to be upsized to fully heat your home, at 10 degrees or low. It's going to have to be cold climate, like the efficient cold climate, not the high efficient. The duct system is going to 90% of the time going to have to be upgraded or upsized, which might be possible and it might not. I mean, if you have a beautiful finished basement, all your ducts are drywalled in, you might not want to rip up half your basement to do that. If your basement is accessible, crawl space, then you can look at it. Because we want to limit electrical strip use, and in the appendix, I have a slide about that. The electrical system, is going to 90%, it's often going to need to be upsized because the electric strip heat also requires a fair amount of capacity. So that happens. So going all electric, you do it, but these are things you think about. The panel upgrade, I think you need to think about it more holistically. When's the time to do it? Contractor questions on sizing. So a contractor size it, ask them what's the changeover temperature. Can I adjust the changeover temperature? That's interesting because the contractor will come in and they really know their stuff, but they do want to be conservative. They don't want you to be uncomfortable. They don't want you to call them and say, this is not working. So if they have a doubt, they might say, all right, I'm going to set the changeover to 25, heat pump mostly 25, furnace below, and you'll be comfortable. But what you can do over time is say, what if I set it to 20? Does the heat pump still keep the house perfectly fine without using the furnace? That might work. And then I've repeated myself a couple times on this, but can I do a few small duct system changes? A good heat pump. How do you know you're getting a good heat pump? Well, cold climate, anything designated cold climate, there's requirements in terms of efficiencies, their variably speed compressors, etc. These are pretty well defined. Here's some names you'll see online. And I also have in the appendix kind of a really detailed slide about this. And remember, there's HSPF and now HSPF2 and SEER and SEER2. So like every piece of equipment has 2 ratings. And then the high efficiencies are good, a little bit less efficient. They operate, some of these even operate to 0, but basically they go down below 15. These are more, you put with the dual fuel. And here's some of the series here. Duct system. Okay, need to check because depending on the generation of ducts, I've been in some houses with spider web ducts. Some it's like, get them out. We don't have a choice. Other one, okay, we can sort of use them. So if they're in a crawl space, they need to be sealed. They need to be insulated. And the contractor is going to look at the sizing. I gave you guidelines, but they can actually go and measure the plenums and everything and say, hey, here's the sizing they'll do. Adding supplies or returns. And they might say, hey, your old duct system, it'll work with a 3-ton, but we should add a couple returns. They're kind of easy to add near the furnace. If you're in a bigger house and you only have one thermostat in the middle, but the trunks there's 2 trunks and one goes to the south side and one goes to the north side, or one goes upstairs and one's the main floor. You can ask the contractor about zoning. It will definitely improve your comfort quite a bit and also have some efficiency. And then just chat with them, what am I going to gain? What do you want me to do with my ducts? What'll help? A couple more slides. Fresh air is becoming a big thing, especially new homes. We're building them super tight. And sure, you can open windows, but you typically don't open windows when it's really cold. when it's really hot, when there's smoke from a fire. So what is these? These are called HRVs. Some of them are called ERVs. What it does is you can hook it. It's a box, 2 feet by 6 inches by 18 inches, hanging up near your furnace or your air handler, and basically it pulls in fresh air, and it goes through this little heat exchanger box. So air that comes in at, instead of air coming in at 10 degrees, the air that goes out that's 70, it exchanges heat. It comes in maybe 45 or so, mixes in and goes out. So you're going to get fresh air without losing a lot of energy, and you can get filter in these also. So you might want to chat about that, especially if you've got allergies and stuff. You can get these plus new filters. Outdoor insulation. These things, they're much quieter, but they do make noise. Think air conditioners running a lot of the year. So don't put it next to your patios that you hang out on. You might not put it under the bedroom windows. You can mount them on the wall, very nice, but they got to make sure you have vibration isolation. You kind of want to help keep them out of the worst weather. So locating the north is the coldest. I mean, if you have to put them in the north, you have to. But kind of try to avoid putting this face right into the wind. Snow and ice, I don't want to shovel it out. You can read the rest of this. And then you're going to have, I realize I put this picture in this mini split, but basically you're going to have an outdoor unit, and you're going to have these lines going into your furnace room, where it's going to connect into the air handler or the furnace. So you can look at these. These can be nice, they can be painted, they can be decorative. But basically, when you think about this, you say, my outdoor unit's going to be here. What's the path to get to my unit? I think I got 2 more slides. Contractors, there's lots of good references. All the sponsors know contractors. This is just some stuff you can check. Let me mention about quotes. People are really busy. Industry's doing great. They're swamped. I get just a couple contractors to come in and get a quote. If they're close within 10%, that's where the market is. If they're way off, then I'd get a third quote. I'd be cautious of the lower ones. And it's unreasonable to compare contractor bids with online pricing of equipment, labor and everything. And it's just the stuff online is always way, like, it makes you think you can get stuff for half of what the reality is. And related to that, you want to get a contractor and good, you're a team. They're going to give you good support. Look at the warranty if you just do online stuff. Remember, this is like buying a car. You want to have a dealer who can provide parts, who can repair it. You don't want to have just order stuff and not having support. So we've gone through the summary, all this, things are great. This is fantastic technology. I highly recommend you look at it, consider it. And in the appendix, I have a couple. This is what Nikki showed, but I do have a couple. This is the chart on credits and specs, and I have also about minimizing electric strip use, etc. So
Thanks, Dave.
I will leave it on this for the moment.
Perfect. Thank you, Dave. I'm going to ask you a few questions. I think Cody's going to help me. So the first one that was asked was, have your slides taken into consideration the forecasted kilowatt hour increase that electricity costs may have in the future?
I put in my slides the kilowatt hour pricing I used for and for gas. You can look at that. I mean, everybody has a different crystal ball. Some people say gas is going to go crazy. Some people say electricity is going to go crazy. The nice thing about the dual fuel option is you actually can respond to that to some extent. So let's say you've got a system. So let's say, actually, let's just say electricity goes crazy. Price. Well, okay, you can turn your set point up a bit and say, use the heat pump down to 35 degrees and then use the furnace when it's cold. But I'll tell you, above about 30 degrees or more, remember that heat pump efficiency isn't 3 times, it's like 3.5, 4, 4.5 times. So it would take electricity, huge prices increases to overcome that and make gas cheap. In fact, it won't happen. So that's what's nice about this. You've got the ability. If gas spikes a lot, you can try to turn your heat pump down a little bit. You're going to be somewhat limited, but at least most of it's going that way. So I don't know. All I know is historically electricity goes up 3% a year. Sometimes there's big jumps, but electricity is so critical to the whole, all of our computers and everything, that the kind of jumps we see in gas, we probably aren't going to happen in electricity. So I don't really want to predict that. I just know with the dual fuel, you've got the best of both worlds.
Looks like we have another question. What kind of vendor availability and certification is there in Colorado for install and service?
It's pretty good. The Front Range is a lot up in Eagle County. Nikki will be able to chime in on this, but like we're working on a big projects, and we've had 1, 2, 3, 4, 5 vendors putting in bids on it. So I mean, I know things are tight. I know that, sometimes it's hard to go out and get quotes, but you can probably get a couple quotes and get people to put it in a couple months. I just had a fast turnaround. It was in Denver, but it was from when I visited them to when the system was in was like 5 weeks. So really fast turnaround. It's
And
a lot
Dave,
better than it was a year and a half ago. A lot.
what specifically do you know about certifications? It says that same person, I'm guessing, I don't know, basically says our current HVAC vendor has stated unequivocally that he is not getting certified for heat pump install or service. So do you know anything about certifications or certification requirements?
Well, there's NATE.
Anything like that?
You can get NATE certification, and you can get certified through a lot of the manufacturers have specific heat pump certification. I mean, I don't know. That's kind of a strange reaction from a contractor. I guess I'd ask them why they're not going to do that. There are sort of, it's not just heat pumps, but all the equipment's evolving, becoming more computer controlled, more sophisticated. So I would be a little concerned about that. But there's NATE and there's manufacturer certification. Those are 2. Some of the utilities are developing, like Excel's developed a list of certified contractors, which means they've come to a couple of Excel's trainings. Some of the distributors offer good training. So I don't know. I'd be a little leery of someone who reacts like that.
Okay, thanks, Dave. Do you recommend having a duct blaster test to determine the air tightness of your duct system and potentially tighten things up before a heat pump is installed?
Well, I mean, if you can get to the ducts to do something about it, sure. But if you can't get the ducts to do something about it, then you have to think about whether you want that cost. I think part of it depends on when the house was built and the quality of the house. If it's an old system and I can see all the ducts in the basement, I look at them, I might not need a duct blaster test. You can just turn it on and see, wow, I've got leaks here or there, fix the leaks, insulate them. So, I mean, I guess it'd be the cost and how big the duct system is. If it's a small duct system, it's probably not worth the cost because you can I would put the money toward just sealing and insulating. If it's a bigger duct system, I've got big ducts out, way up in the attic. I don't really know, then it would be worth considering.
Thanks, Dave. Cameron, just to divert your attention, go to Q&A. You have your own question in the Q&A. The next question, Dave, is what kind of issues are you running into when adding a heat pump to a property that does not have AC condenser on the outside of the home, and now there will be one there? Subdivision issues, neighborhood issues, space issues.
Well, the biggest issue is, okay, so let's just look at it from the homeowner's point of view to start. Number one, where you're putting it, you have to think about, like I mentioned, ideal locations. But you also have to think about what's the pathway to get the lines into my furnace room if the inside of my basement fits. Okay, with neighborhood issues, sound is like sound. And there's ways to deal with that. Some of my recommendations, there's two recommendations. One is a landscape wall. So like you could easily build like landscape bricks, say a wall that's like 4 feet high, 4 feet wide. It has to be a little bit away from the heat pump. There's specs on how close. So, you know, your neighbor doesn't necessarily see it, and that's going to have a big effect on keeping the sound away. There's also for some of the sort of the, not the box, the square heat pump designs, but sort of the thin, longer ones, I've been looking at, you could actually build a nice box with 2-inch sound absorbing inside. You have to make it big enough. It's almost like an outdoor bar, 5 feet by 5 feet by 2 feet. And you can put sound insulation in it. That does a couple things. It insulates it, protects it from snow above and the weather. You just have to make sure that, you know, you've got enough room around it, but you can do that. And also there's some nice made boxes on the internet. Etsy, you can order a really nice one for like $500, louvered and everything. So there's ways. I mean, the neighbors really comes down to the sound. And those are some of the things you can do.
Okay.
My neighbor put one in about 20 feet from my deck, and it's not bad at all.
Awesome. Thanks, Dave. We have a question from David Mickey. What is the amperage and voltage for the strip heater?
Let's see, do I have that in? The amps can be really high. Let's see if I can pull it up really fast. Actually, I'll add that in. I'll add that in the appendix. The strip heater amps can be super high, like 220, 60 amps. Anywhere from typically, you're going to put in like a 10 kW. So typically you'll put in 10 kW, 15 kW, and you'll put them in 5 kW increment. They'll fire in 5 kW increments. So it does add. That's the hard part with the strip heaters, is essentially think of it, you're almost doubling your electrical requirements. So that's, I will add that in. I have a table. I don't want to spend time looking now. I do have a table made up, which has like strip heater, BTUs, etc. Did I just do this? Is this thing?
Well, thank you everybody for attending today. Dave, I think that's all of our questions. As you can see on the screen, the next webinar is July 26th. You can sign up online and please reach out with any questions at all. We will be sending a follow-up email out with all this information. Thanks everybody. Have a great night.
Thank you, everyone.